sir.
లాస్ట్ క్లాస్లో ఉన్నావా?
Lane, sir.
ఓకే, అయిపోయిందా పీసీబీ డిజైనింగ్? ఇంకా ఉందా? నాట్ అట్ ఆల్ గోయింగ్.
ఈరోజు 3 పెట్టారు సార్.
ఈరోజు 3.
వాళ్ళు 3కి పెట్టారు. దెన్ వాట్ అబౌట్ రిమైనింగ్ స్టూడెంట్స్? రెస్ట్ తీసుకుంటున్నారా ఏంటి? Only 15 people are there still. జాయిన్ అవ్వడానికి 3కి అయితే 250 దాకా క్లాస్ కదా. Okay, we'll go on. Okay, see here, this is the yesterday's class conclusion of those steady state errors. The first table belongs to static error constant with respect to inputs. That means type numbers, type 0, type 1, type 2, type 3. That means for KP will come only when the input is unit step, and for the unit ramp input, let me highlight this now. Yeah. See here, this is unit step input. Unit step means you will get the KP, that is positional error constant. For unit ramp, that means KV you will get. For unit parabola, you will have KA, that is acceleration error constants. So for type 0 system with unit step, that means KB, you will have the constant value. For type 1, 2, 3, you will get infinity value. Similarly for KV type 1, here power, what is the power here? At that type only you will get the constant values. Suppose if you take this KV, here t power 1 into e of t, so power 1 is there. So for type 1 you will get the constant value. Here t power 2, but that means for KA you will get at power 2, you will get the constant value. Remaining terms depends on the S values, means denominator and numerators. Similarly, ESS also you will get like that only. T power 0 means for type 0 you will get the constant some value. T power 1 means for type 1 you will get 1 by KV, that may be some value. That is not 0 and that is not infinity. Basically, you will have, means if you want to find ESS or any static error constants, you will have mainly 3 outcomes, 3 outputs will come. Those are, one is 0 and one more is infinity and one more is constant. Constant means that depends on the input. See, I will write here. You will have mainly 3 inputs, 3 outputs are there. 3 outputs. That means you may get out ESS or else KV, KP, KP, whatever may be. ESS, that may be 0 or that may be infinity or that may be constant. These 3 only the outputs you have. These 3 only the outputs you have. So I already concluded something from this ESS table. That is, if type and input are equal. Inputs means you have 3 types of inputs: unit step, unit ramp, and unit parabola. And type means depends on the given equation, type 0, type 1, type 2, like that. Whenever you have both type, that means given question and given input are same, those 2 things, powers, type and inputs are same, then you will get the error is constant. If type is greater than input, type is greater than the input, then you will get the ESS is 0, and type is less than the input means you will get the ESS is infinity. Okay, now So based on this, I will tell you some things here. Let me write. Please write that one. Please respond this. First of all, type of the system and input, ESS. Input or error constant controllers. Next, ESS. Error constants. So what are the three types of error constants we have? First of all, what are the three error constants we have? Respond. మనకున్న error constants ఏమేంటి?
Positional acceleration, velocity.
Okay, positional acceleration and velocity error constant. So those are Kp, Kb, that means velocity, and Ka. So for which input these are constants? For which type? First of all, tell me what is the type of this positional error constant? What is the type? Type ఏంటి? Type 0 సిస్టమ్ కా లేకపోతే టైప్ 1 సిస్టమ్ కా టైప్ 2 సిస్టమ్ కా పొజిషనల్ ఎర్రర్ కాన్స్టెంట్ మనం ఫైండ్ అవుట్ చేయగలిగేది? ఫర్ టైప్ 0 సిస్టమ్స్ ఆర్ టైప్ 1 సిస్టమ్స్? చెక్ ద నోట్స్.
Zeros.
Type 0 system. Very good. So type 0 system, you will have Kp, that means positional error constant. Type 0 system. And similarly, if you want to get the constant value, that means ESS should be constant. If you want to get the constant values, that means error, steady state error, if you want the constant value, the given type is type 0 system and given error is Kp. For which input you will get the constant value, ESS? For which type of input you will get the constant value? Unit step. Very good. So that means for unit step input and for type 0 system, you will get the Kp is constant. So that becomes ESS also what? Constant value. So remaining, next, Kv. Kv means velocity error constant. Same here also. For which type and which input you will get the constant ESS and constant velocity errors? What is the type of this system? First of all, velocity error. Type 1. Wait a minute now. Yeah, what is the type? 1, that means Kv. What is the input here we have to apply?
Unit ramp.
Unit step.
Sorry, it is unit step input, that means Kp. Kv means unit ramp. For type 1 system, Kv, that is error, velocity error constant you will get. For that, if you apply unit ramp input, you will get the constant value, that is ESS. ESS you will get is constant value. Similarly, what is the Ka, acceleration constant? What is the type of this acceleration constant?
Type 2.
Type 2. That means for type 2 system, you will get acceleration constant, and to get the error constant is, sorry, ESS is constant. You have which type of input you have to apply?
Unit parabola.
Unit parabola. So if you apply unit parabola on type 2 system, that means for type 2 system with unit parabola input, you will get the constant ESS value. So remember these three things. Please note on this also if you want. Kp, Kv, Ka. Kp is for unit step input on type 0 system. You will get constant steady state error. Similarly, for type 1 with unit ramp input, that means velocity error constant you will get. There you will get the constant steady state error. Similarly, for type 2 system and with unit parabola, then you will get the constant ESS. So suppose ikkada unit step input ichchanu, but type 1 system. So what is the value you will get? ESS? Type 1 with unit step input. Type 1 with unit step input. What is the value you will get here? ESS. Type 1 with unit step input.
0, sir.
0. That means type is greater than input on. Yes or no?
Yes, sir.
Yes. Conclusion చెప్పాను కదా మీకు, అందుకే ఇక్కడ టైప్ ఈజ్ గ్రేటర్ దాన్ ఇన్పుట్ అయితే ఏంటి, టైప్ ఈజ్ లెస్ దాన్ ఇన్పుట్ అయితే ఏంటి. ఈ సింగిల్ స్లైడ్ లో మొత్తం తెలిసిపోతుందమ్మా. క్లియర్ గా అబ్జర్వ్ చేయండి దీన్ని. సో కంప్లీటెడా ఈ పాయింట్స్ వాటికి కంప్లీటెడా?
Completed, sir.
What about remaining?
Yes, sir.
PCBDM క్లాస్ ఎప్పటి నుంచి అమ్మా? 3 నుంచా?
Yes, sir.
Okay. Alas, please note on this problem. Tell me what are the steps I have to find this. What is the given data and what you have to find? Completed? Complete and the question? Question complete and now. Yeah, okay, done. Given system is open loop transfer function with the type of input signal. They are asking explain what type of input signal give rise to a constant steady state error. They are asking for which type of input signal you are applying. So there is a 3 questions they have given there. We will go with the first question and calculate their values also they are asking. Okay. It means for which type of input, if we apply to particular question, for that input we need to get a constant steady state error. They are asking for which type of input, means ఏ ఇన్పుట్ అప్లై చేస్తే మనం కాన్స్టెంట్ ESS అనేది ఫైన్ వస్తుంది. So you have to find those things. First question, First, write down first one thing. That is 20 into s plus 2 by s into s plus 1 into s plus 3. మనం ఏ ఇన్పుట్ అప్లై చేస్తే యూ విల్ గెట్ ద కాన్స్టెంట్ ఈఎస్ఎస్. దట్ ఈస్ వాట్ దే ఆర్ ఆస్కింగ్. ఫస్ట్ ఆఫ్ ఆల్ యూ నీడ్ టు చెక్ ద క్వశ్చన్స్ ఇన్ ద గివెన్ క్వశ్చన్. వాట్ ఈస్ ద టైప్ ఆఫ్ దోస్ క్వశ్చన్స్? ఫస్ట్ క్వశ్చన్ టైప్ ఎంత?
1.
ఫస్ట్ క్వశ్చన్ టైప్ 1. నెక్స్ట్ సెకండ్ క్వశ్చన్ కి టైప్ ఆఫ్ దిస్ సెకండ్ క్వశ్చన్
0.
0. 0, sir.
థర్డ్ క్వశ్చన్
2.
2. Very good. So coming to this first question, g of s is 20 into s plus 2 by s into s plus 1 s plus 3. Now let us assume given feedback am ichada h of s unity feedback system. So what is the value of h of s and if it is unity feedback means
1.
h of s equals to 1. So that's it. So now we have to find the constant ESS. So what is the type of this system now? It is type what is the type 1 system. So ఇప్పుడు ఏ ఇన్పుట్ అప్లై చేస్తే you will get the constant value, constant ESS. What is the input you have to apply, whether it is step input or ramp input or parabolic
ramp
input? Unit ramp. Very good. So for unit ramp input with type 1 system you will get the constant ESS. అందుకే ప్రీవియస్ గా చెప్పాను. So the open loop system, write down. The open loop system has how many poles are there? How many poles are there? Origin poles.
3, sir.
Origin pole I am asking, not denominator poles. Origin pole means s plus 1, s plus 3. There is only one origin pole. One pole at origin. That means origin poles gives the type of the system. Origin దగ్గర ఉన్నటువంటి poles ఆ పవర్ ఎంత అయితే ఉంటుందో that will give the type of the system, type. So it has one pole at origin, hence it is a type 1 system. Type 1 system. So in systems with type 1, what is the input? What is the input you have to apply? The ramp input. Ramp or else you can call it as velocity input. The ramp input in systems with type 1, in systems with type number 1, the ramp and the ramp input will give a constant ESS. That means steady state error. Question లో అదే అడుగుతున్నారమ్మ మమ్మల్ని. What type of input signal will give rise to the constant ESS? ఏ ఇన్పుట్ అప్లై చేస్తే you will get the constant ESS అని అడుగుతున్నాడు. So for the first question, if you apply ramp input, you will get the constant ESS. What is that ramp input? That means the steady state error with ramp input. That means ESS equals to, what is the relation between ramp input and this ESS? ESS equals to velocity input. Entadi ESS ki KV ki relation. ESS and KV relation.
Limit s tends to
No. Relation between ESS and KV. Velocity error constant.
1
Right?
by
1 by
kV.
kV, sir.
1 by kV.
ESS equals to 1 by KV. The steady state error with ramp input or velocity error input, you can call it as ramp or velocity. So now KV means velocity error constant. That means kv equals to limit s tends to 0.
S
What is
into
that?
G of S into H of S.
S into g of s into h of s. So what is h of s and what is g of s? Substitute those values. Limit s tends to 0, s into g of s means 20 into s plus 2 by s into s plus 1 into s plus 3 into h of s is 1. So what is the value of this one? Apply limit and then tell me the answer. So this s and this s will get cancelled. So remaining is 20 into 2 by denominator 1 into 3. So what is the value on? Use the calculation, tell me the answer. Now by using this steady state error ESS equals to 1 by kV. So that is equals to 1 by this value. So that is what we have to find. ESS. We need to find the value of steady state error. kV ఎంత వచ్చింది? G4
40/3.
40/3. Okay, in terms of factors, what out meant 40/3. So 1 by kV means 1 by 40/3. So that becomes 3/40. So what is the fraction of this one? Fraction point ఎంత వచ్చింది?
0.075.
0.075.
00 na 0.75.
అంతే సార్ కరెక్ట్.
0.075.
0.075.
Yeah, okay, done. Next, similarly for second question. So that is ESS. They are asking that only. What type of input signal give rise to a constant ESS? For the following or So for the first question, type 1. So for type 1, if you apply unit ramp input, then you will get the constant. Similarly, what is the second question? And what is the type of that question? Second one, G of S ఏంటి?
సార్ ఒకసారి వెనక్కి వెళ్దాం.
Second question type ఎంతమ్మా?
G of S
0
into
sir.
GMT.
Type of this second question. I'm asking type
0 sir.
type number. So for type 0 system, what type of input we have to apply to get the constant ESS? For type 0
Unit
system,
step. Unit step.
Yeah, very good. So go ahead with the same procedure. As it is గా రాసేయండి. Type 1 on chota type 0 system, ramp on chota unit step, and remaining as it is. KV. So unit step means what is the static error constant notation? K.
1/1 plus K.
Yeah, 1 by 1 plus kp. That is ESS. Where kp is called
Positional error constant.
positional error constant. So we here G of S equals to 10 by S plus 2 into S plus 3. Here also always assume unit feedback system, unity feedback system. That means H of S equals to 1. So given is G of S means that it is open loop or closed loop system. అది ఓపెన్ లూపా క్లోజ్ లూపా? G of S ఇచ్చాడంటే
Closed loop.
క్లోజ్ లూపా? ఇచ్చిన క్వశ్చన్లో G of S మాత్రమే ఇచ్చాడంటే అది ఓపెన్ లూప్ సిస్టమ్ అనా క్లోజ్ లూప్ సిస్టమ్ అనా?
Open loop, sir. H of S into closed loop.
Next, write down here the open loop system has how many poles at the origin? How many poles are there in this case? Origin poles.
0.
Origin poles అంటే S పవర్ లో ఎంత అయితే ఉంటాయో those are origin poles. S term. S power లో 0. That means no origin poles here. So the open loop system has no pole at origin. That means so it is a type zero system. Suppose origin poles దగ్గర 10 ఉంది అనుకోండి. What is the type of that one? S power 10 ఉంది అనుకోండి.
Type 10.
So the type is 10. So it is a type 0 system. So in systems with type 0 and the what type of input you have to apply?
Unit
Step input.
sir. Step input.
And the step input will give a constant ESS. Do it fast, write down. Fast write down. The ESS with the unit step input is ESS equals to, what is the relation between this ESS and unit step? 1 by
1 plus Kp.
Yeah, where Kp means positional error constant. So the positional error constant is Kp equals to limit s tends to 0. S tends to 0.
G of s
G of
into
s
h
into
of s.
h of s. So that is equals to limit s tends to 0. G of s means 10 by
10 by
s plus 2
into s plus 3.
plus 3. So h
Into
of s is 1. So directly apply here, you will get 10 by 2 into 3. Means substitute wherever s is there, put s equals to 0. So this becomes 5 by 3, right? That is Kp value. That implies ESS equals to 1 by 1 plus Kp. That means 1 by 1 plus 5 by 3. So 3 by denominator 3 plus 5. So it is 8. So 3 by 8 means
375.
Okay, done. That's it. Similarly, third question also. Do yourself and tell me the value. So first of all, what is the type of that system?
2 sets.
2. So A input ఇవ్వాలి ఇప్పుడు 2 కాబట్టి type 2 అంటే
Acceleration. Ka.
yeah, parabolic or acceleration. That is 10 by s square into s plus
S
1
plus
into
1 into s plus 2.
Similarly, here also assume unity feedback system. That implies h of s is 1. Because academy mention చేయలేదు. So you can take default like this. Remember. Similarly here, how many poles are there? Origin poles?
2 sets.
Very good. 2 poles are there. The open loop system has 2 poles at origin. It means that it is a type 2 system. So it is a type 2 system. So in systems with type 2 and what is the input? Parabolic or else acceleration. Acceleration input will give constant ESS. So that means ESS with unit parabolic. Unit parabolic input ESS equals to 1 by
Ka.
Ka. So that implies k equals to limit s tends to 0.
H square into 0 of s into h of t.
Yeah, substitute those values and find out the ESS also. H of s is 1, right? So that is equals to these two gets cancel s square terms. So remaining is 10 by
2, sir.
1 into 2. So that is equals to 5. So now ESS equals to 1 by Ka, that is equals to 1 by 5, that is equals to,
0.2.
yeah, that's it. That is the left ESS. Completed, huh? Yeah. Next. This is one type of problems we may ask, and the next type is add on this problem, and then we'll finish this errors concept by tomorrow or the next class. I'll start the third unit. Next week lo third unit అయిపోతుంది. So after the classes మనకి అవన్నీ don't want to waste my time. Only 20 people are attending in afternoon sessions. So keep it in mind, and third unit is the smallest one. And easiest one also. Write on this, the open loop transfer function of the servo system with unity feedback is g of s is 10 by s into 0.1s plus 1. 0.1s plus 1. Evaluate static error constants of the system. First question. So, and then obtain steady state error of the system when subjected to an input given by the polynomial, that is r of t, that equals to a0 plus a1 into t plus a2 by t into a2 by 2 into t square. a2 by 2 into t square. ఫస్ట్ ఆఫ్ ఆల్ ఇచ్చిన క్వశ్చన్ కి ఆర్ ఆఫ్ టీలో ఆ టైప్స్ చెప్పండి. ఫస్ట్ ఆఫ్ ఆల్ ఎన్ని ఇన్పుట్స్ ఉన్నాయి ఆర్ ఆఫ్ టీలో? ఆర్ ఆఫ్ టీ మీన్స్ ఇట్ సెల్ఫ్ ఇస్ ఎ ఇన్పుట్, అండ్ హౌ మెనీ ఇన్పుట్స్ ఆర్ దేర్, బికాస్ ప్లస్ సైన్ ఇస్ దేర్. సో హౌ మెనీ ఇన్పుట్స్ ఆర్ దేర్? How many inputs are there? ఇన్పుట్స్ ఎన్నో ఉన్నాయి ఆర్ ఆఫ్ టీలో? పాలినామియల్ అన్నాడు, సో సమ్ డిగ్రీ వరకు ఎక్స్టెండ్ చేసుకుంటే వెళ్తాడు. సో వాట్ ఆర్ ద మ్యాక్సిమం డిగ్రీ అండ్ హౌ ఇట్ మీన్స్ డిపెండ్స్ ఆన్ దట్ హౌ మెనీ ఇన్పుట్స్. 2 inputs only. Today we will check it again, and you have to tell the type of that inputs also. First given no yeah, very good, 3 inputs. First given transfer function యొక్క టైప్ ఎంత? ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క టైప్ ఎంత? 0. దట్ మీన్స్ బికాజ్ ఆరిజిన్ పవర్ లో ఎంత ఉన్నా పోల్స్, టైప్ ఎంత దీనికి? 0 నా. Type of the transfer function s power 1. So this type is 1. So r of t ki any inputs ఉన్నాయి? r of t is itself is the input, and it is having summation is there because they are saying that polynomial, it may extend to some nth degree, right? Nth polynomial antam kada. So like that you will have a0 is one input, a1 into t is the one input, and a2 by 2 into t square is the one more input. So you will have combinedly 3 inputs are there. With this, in this, what is the type of this first one, a0? What is the type?
0, sir.
0, because you can write as a0 into t power 0, right? Yes or no?
Yes, sir.
Similarly, second term యొక్క type ఎంత?
1, sir.
So similarly here, third term
2.
Type 2, because t power లో ఎంత అయితే ఉంటుందో that comes to that is nothing but type of the value. So now tell me, for which type of input you will get the constant ESS? For which input you will get constant ESS? Whether A0 కా లేదా A1 into t కా లేదా A2 by 2 into t square కా? కాన్స్టెంట్ ఎప్పుడు వస్తుంది? ఇక్కడ ఇన్పుట్ ఏంటి?
A1 into T.
టీ, A1 into t. వెరీ గుడ్. ఎందుకని? ఎందుకు A1 into t?
1 కదా సార్.
Yeah. So type equals to, yeah, type and input. Yeah, type is 1. So if you apply input also 1, then you will get yes or no? ఆ టేబుల్ చెప్పాను కదా, టైప్ ఈక్వల్స్ టు ఇన్పుట్ అయినప్పుడు మీకు ఏమొస్తుంది ఎర్రర్? టైప్ ఈక్వల్స్ టు ఇన్పుట్ అయితే కనుక యూ విల్ గెట్ ESS ఈస్ కాన్స్టెంట్. సపోజ్ A0 ఇచ్చామనుకో GFS కి, అప్పుడు టైప్ కి ఇన్పుట్ కి రిలేషన్ ఎలా ఉంది?
గ్రేటర్ దాన్.
టైప్ మీన్స్ ఇదమ్మా, దిస్ వన్. టైప్ ఇన్ ద సెన్స్ GFS లో ఉండేదాన్ని టైప్ అంటారు. మనం ఇచ్చిన ఇన్పుట్ యొక్క టైప్ వేరు, ఈ టైప్ వేరు. దిస్ టైప్ మీన్స్ గివెన్ ట్రాన్స్ఫర్ ఫంక్షన్ టైప్. సో దాని టైప్ ఎంత? టైప్ వాల్యూ, ట్రాన్స్ఫర్ ఫంక్షన్ యొక్క టైప్ వాల్యూ
1 sir.
So this is 1. And what about input? A0 having some type, that is t power 0. So it is 0. Input is 0. So whether it is greater than 0 or less than 0?
Greater than 0.
So type is greater than input means what is the ESS you will get?
0.
0. So similarly for third term, what is the type? Type is 1. And what about input here now? Input having the type
2.
2. So what here the case is less than or greater than?
Less than 0.
So less than means what is the ESS?
Infinity.
Infinity. In simple way, substitute all those things here. So A0 కి ఎంత వచ్చింది మనకి?
0.
This is A0 case and this is A1 case and this is A2 case. So A0 కి ఎంతమ్మా? 0 plus A1 కి some constant plus A2 కి వచ్చేసరికి ESS అంతా infinity. So total answer becomes ఎంత వస్తుంది ఆన్సర్ ఫైనల్ గా? 0 plus constant plus infinity. What is the value? Infinity only, no? అరే యార్, అడిషన్ లో కానీ సబ్ట్రాక్షన్ లో కానీ ఇన్ఫినిటీ ఉందంటే ఇన్ఫినిటీనే వచ్చేది. ఓకే, బిఫోర్ గోయింగ్ టు ద ప్రాబ్లమ్, దట్ మీన్స్ బిఫోర్ గోయింగ్ టు ద యాక్చువల్ ప్రొసీజర్, by using these 3 things which I told you in the last class, you can find the what is the ESS for the given input. By using this value, you can find directly what is the output. ఒకవేళ మీకు అవుట్పుట్లో చెక్ చేసుకోవడానికి ఈజీగా ఉంటుంది, ఇది మీరు కరెక్ట్ చేశారా రాంగ్ చేశారా అని చెప్పడం కోసం. If you want to know whether it is correct or not, your procedure, you can directly go through this procedure only. The best thing. This is not there in the textbook. Okay, now, if you want, if you note down, or else no problem. I will go through the standard procedure. And now, first one is they are asking static error constant. That means Kp, Kv, and Ka you have to find. So first thing is Kp. Kp means, and given here is unity feedback. What is H of S? H of S is how much? H of S is 1. Okay.
1.
So first find out static error constants. That means Kp, Kv, and Ka. So first one is positional error constant. Position error constant, and that means Kp, that is equals to limit s tends to 0, G of s into h of s. So what is the G of s given? G of s means 10 by s into 0.1 into s plus 1 into h of s is 1. So apply, if you apply s tends to 0, what is the value? Kp value becomes 0 into something, 0 plus 1. So it is 10 by 0. Anything by 0? Anything by 0? So nobody is responding, right? Okay, no problem. It is infinity. So next one is velocity error constant. That means kv. Limit s tends to 0. Kv means
S
s,
into G of S into H of S.
yeah, okay. S into g of s into h of s. So that means limit s tends to 0, s into 10 by s into 0.1 s plus 1. So you will have a cancellations. This
S
s
S
and this s. So that is 10 by remaining term
by
0 plus 1.
0 plus 1.
That is 10. So constant value you are getting, because given question, given transfer function is type 1 system. So type 1 with unit ramp will get a constant value. The next third one is acceleration error constant. That means Ka, which is equals to limit s tends to 0.
S square into G of S into H of S.
Yeah, so that is limit s tends to 0, s square into 10 by s into 0.1 s plus 1. So there is a cancellation of s square and s. So remaining in the numerator you have s term is there. So that becomes, if you apply s tends to 0, 0 into 10 divided by 0 plus 1. So numerator 0 by 1, that is equals to 0. So this is Kp, Kv, Ka values. So the next term, the next you have to find is ESS, right? So we see in the next class. It's already time over. Next class, ಯಾರು? Next class,
CA.
Yeah, it's me. If you want, you can take another 5 minutes. Complete it.
okay, sir. It will take more than 10 minutes. No problem.
Okay, if you want, you can take noise. You will wait for him. You want to finish the topic?
Yes, sir.
Okay, finish it. We'll wait. Noise.
Yeah, okay, sir. So, come on, find out this ESS now. I'll tell the detail and then you'll find it. No problem. So, our target now is you have to find the ESS. That means steady state error. For that first one, what is the error signal? E of S means E of S. What is the formula for that?
R of S by 1 plus G of S into H of S.
Yeah, very good. R of S by 1
1
plus
plus G of S
G of
into
S
H
into
of S.
H of S. That is error signal in domain. Right? So that is
Sir, మీది PPT stuck అయింది సార్.
okay now. Yes or no?
No సార్.
లేదా?
బ్లాంక్ గా ఉంది సార్, రావట్లేదు.
Yeah, okay. ఇప్పుడు
స్టాప్ అయిపోయింది సార్ షేరింగ్.
Just 5 minutes, I'll finish, no problem.